Do you guys have any questions about anything? Now, if you missed classes, it's important you watch the video because I have covered some things which probably aren't in the book just yet, but I think they're useful to you. I will do one of those here. All right, so what I did was this thing called completing the square, right? And so what this is it's a way we can factor with confidence. So example 1, suppose you want to factor x squared, plus 4x minus 9. So the thing is, if you just tried the guess and check method, would it work here? What do you guys, you think you can do it? So if we just put down like this, can you factor that? What do you think? So I can't. I mean, I would try 3 and 3, right? Or 9 and 1. And like, if I use 3 and 3, I get a 6 for my cross term. If I use 1 and 9, I get like either a 10 or an 8, plus or minus, whatever. I can't get 4, right? So this is hopeless. So how do we factor this? We need a different way. And so the other way to do it is to do completing the square. So completing the square, what you do is you take half of whatever's here. So that would be what? 2, right? So I put x plus 2, I square that. Now, to be fair, what I've just done is I've added 4, right? Because if you square this out, what does that equal to? Yeah, this quantity right here is just literally x squared plus 4x plus 4, right? Now, do I have x squared plus 4x plus 4 over here? I do not, right? I just have x squared plus 4x. So to be fair, I have to subtract 4. And I still got the minus 9, right? That is what is completing the square. That's it. The thing is, once you do this, you can finish the problem by the difference of squares formula. Or you can recognize it's impossible. So what's the difference of squares formula? A squared minus b squared is a minus b, a plus b, right? This is the difference of squares formula. So here, if you look at it, tilt your head and squint, you can see I've got x plus 2 squared minus 13, right? But 13 is the square root of 13 squared. Got to use your imagination a little bit, but 13 we can write as the square root of 13 squared, right? And then I have the difference of squareds. See, I can think of this as like a, I can think of this as like b squared, right? So the answer is x plus 2 minus the square root of 13, x plus 2 plus the square root of 13. There you go, factored. I would point out, in the completing the squares method of factoring, there's no guessing. You take half of the thing, you subtract it, the square of it after you put the square, and then you just do difference of squares. Like, there's no guessing here, right? And another example. So, and I don't think this is technically in your book until like chapter 7, okay? But I can't not talk about this now. It's just not in me. So here's another one. If I had x squared plus 6x plus 20, complete the square. So this time I would do x plus what squared? I have to do what? If I got a 6 here, to recover back x squared plus 6x, I must put half of 6, which is 3. See, if I put a 3 there, then when I take x plus 3 squared, I get back x squared plus 6x, and then I get an extra 9, right? So to be fair, I have to subtract 9. And I still got the plus 20, right? And then, okay, so clean it up. This is x plus 3 squared plus 11. Once you get to this, guess what? Game over. You cannot factor this over the real numbers. So that shows you that this is a quadratic which cannot be factored over the reals. Does not factor over R. This is another symbol for minus infinity to infinity, right? Now, one more example, and then I'll stop with this for today. Example 3. What if we did completing the square on, say, x squared plus 10x plus 25? So we do x plus what squared? Take half of 10. Half of 10 is 5, right? And then we have to subtract the square of the 5, which is 25. But we still got 25. Oh, look at this. X plus 5 squared. Factored. Now, could you have done this without completing the square? I think you could, right? I think if, in example 4, I put, x squared plus 16x plus 64, and I just say, okay, fill in the blanks for me, I think you can do it. Can you tell me how that factors? You're like, you just got done telling me complete the square will make it so I don't have to guess. Now you want me to guess? Make up your mind already. My point is you got options. 8 and 8. See, because 64 is 8 times 8. 8 plus 8 is 16. We have a winner. So that's good. But my point to you is if you didn't have that insight, if you get stuck on a factoring problem, right? Whenever you get stuck on a quadratic factoring problem, if you understand completing the square, you can fall back on it and factor it. It's foolproof. It's a foolproof method. Okay, so now we should turn to the next kind of factoring problem that we have to confront, which is factoring by grouping. Factoring by grouping requires a little bit of sneakiness. So let's look at some of these. Let me find a bunch of examples for us to do here. There's this thing called an index, so I could figure out where they are if I looked in there, couldn't I? My students always give me grief over not using the index, but I feel like it's cheating, Grouping method, page 319. All right. Okay. Yeah. All right. Well, those aren't exactly more. I think I want the more factoring by grouping, which is actually in the next section here. All right. I'm going to have to make up some examples because your book is disappointing me. I mean, the examples I want, they're probably in the book. They're just not jumping off the page at me at the moment. All right, so example 5. So some of these examples are just kind of preachy. All right, so let me show you a very preachy example. Factor x cubed times x squared minus 7 plus x plus 1 times x squared minus 7. Now there's a wrong way and there's a right way to solve this problem. The wrong way is to put your brain in neutral and just multiply them out because, hey, I know how to do that. That's what I would have done as a student. I'd have thought, oh, I know how to multiply these. I'm going to do it. But if I did that, I would completely destroy, the goodness which is just sitting here. So the point is, you've got the same thing here and here, right? It's a common factor. That means we can factor it out. And that, in a nutshell, is factoring by grouping. There you go. That's it, factoring by grouping. I'll do another example. X cubed plus 5x squared plus x plus 5. Let's try to use the factoring by grouping idea to help factor this. So you got to kind of like look at it and go, wait a minute, the first two terms I can factor an x squared out of, right? So I've got like x squared times x plus 5. That gives me those first two terms, does it not? Do you agree this guy and this are the same? Right? If I multiply this out, I get x cubed plus 5x squared, right? So my insight is to say, wait a minute, there's an x plus 5 hidden in here, and that's just x plus 5, right? So what can then I can use factoring by grouping. See, because this is really x squared plus 1 times x plus 5. That 1 I have to put there because this one right here is what's bringing that 1 into play, okay? This is factoring by grouping. I will mark you attended. Of course. Is there a particular one you'd like me to do? Okay. Yeah, I mean, I think I agree with you in the sense like these take longer to kind of glom on to what's going on here. Example 7. If we had x squared minus 2x plus 1 plus I'm sorry, this example is too horrible. Recalculating. Come on, book, give me a decent example here. Sometimes this book is getting on my nerves. Oh, there's one. All right, finally, here they are. I found them. Cubed minus 7 squared minus 4 plus 28. So this is like number 57, section 4.6. So if you guys, make sure you watch videos if you're gone other days. We've covered bits and pieces of most of chapter 4 at this point. Okay, so what do you guys think about this one? So the first two pieces, see, I can factor m squared out of the first two, right? I've got m squared times m minus 7. So this is part of factoring by grouping is, like if you got a couple terms and they just very suspiciously allow you to factor them, then the way these problems tend to be constructed is the other piece, whatever you're left with, is going to be that same kind of thing. So you should go looking to see if you can find an m minus 7 hidden in here. Can you? What is this? This is minus 4 times m minus 7. See, that's a little bit tricky. Minus minus gives me plus, but 4 times 8 is 28. Right? And I got the minus 4m. And then I've got a common factor of m minus 7, right? So this factors to m squared minus 4 times m minus 7. That's factoring by grouping. Can we go further on this problem? What if you wanted to completely factor this expression? What would be left to do? Right, get rid of the square. We can factor m squared minus 4. How does that factor? That factors to m minus 2, m plus 2, m minus 7. Yeah. And whether or not the book wants you to make that final step for the problem, it depends on the particular whimsy of the book on the problem. I hopefully will be more clear on the test. On the test, on the test, it depends on the instructions. So if I say factor completely over R, then you need to. So this is just factor by this. So like at this point, I've factored by grouping. All right. So I've made it. If the instructions were just factor by grouping, I've done that there, right? If the instructions are factor the polynomial completely over R, then this isn't the answer, that's the answer. See, because you can break down m squared minus 4 into the product of this and that. So, if in doubt, ask me on the test. I'll tell you if you're done or not, you know. Okay, let's see, let's look at another one. Whale. Okay, this is number 66. Here we have x squared minus 2xy plus y squared minus 25. I'm supposed to try to factor this thing. Any ideas? These first two pieces, does that, if I put this like that, can you see how to factor these guys? Put an x here. So this one, by the way, this problem right here is not factoring by grouping. It's something else. This is, what is it? This problem not factoring by grouping, right? This one actually is just something else. Something else. So can you guys see what to do there? So I'm trying to just put the x's and the y's together, right? So if I want a y squared here, I could do what? Like y times y? So I should at least try, you know, plus y maybe. I mean, I don't know, does that work? I don't think that works because then I get plus yx plus xy, right? So I get a plus 2xy for my cross term. I got a minus 2xy. So I should adjust my guess, right? Change it to minus and minus. Maybe that works. Does that work? X times x gives me x squared. Minus y times minus y gives me y squared. Good. And then my cross terms, minus yx and minus xy, combine their like terms to give me minus 2xy. Hey, so we got it. Well, we're not done yet. We can do a little bit better. This is x minus y squared. And let me write that 25 as 5 squared. Now you can recognize, aha, difference of squares. Right? And remember, one of the things we should always keep in mind is that a squared minus b squared is a minus b times a plus b, right? So as soon as we see that difference of squares, we're like, aha, we're in the home stretch. We know what to do here. This is x minus y minus 5, x minus y plus 5. And so that's how you do a problem like that. There's a few problems like this in this section. Let's see if I can find another one to work here. I'd really like another one like 57. Oh, 58's kind of similar. I'll work 58. Number 58, we've got x cubed plus 8x squared minus x minus 8. And it tells us factor. So what do you guys think? Do you see anything? Oh, we can factor x squared out of these first two terms, right? What's that give us? We got an x, right? And plus what? Plus 8, right? Ooh, x plus 8. Is there an x plus 8 sitting here? How about this? This is minus 1 times x plus 8, isn't it? See that? So these two terms go to that. And these guys become this. As you can see, now we can factor by grouping, right? Because we've got a common factor of x plus 8. So the distributive property gives me x squared minus 1 times x plus 8. Now, so if we just were factoring by grouping, great, we're done. If we wanted to factor completely, we're not done, right? We can do better. Because what else can we do? Can we factor that more? We can, right? This is x squared minus 1, which if you look at 1, is 1 squared, right? 1 is 1 squared. So this is a difference of squares, which means I can use this property on it. That's x minus 1, x plus 1, x plus 8. Now there you go. It's factored completely. So that's that one. All right, I'm going to look at some of the cubic problems from section 4.7 with you guys. See if we can do them. Ooh, this one. Look at this one. Number 45 from section 4.7. Here we face a to the 8th minus b to the 8th. How are we going to handle this guy? And before I forget, I'm going to put number 57. That'll be the next problem over here. Number 57 looked good. It's going to be 8x cubed plus 44x squared plus 60x. We'll work on factoring that guy over there next. And then I'm going to jump to the end of the chapter and work some rather different problems for the rest of today. So if you go back and watch the last two classes, we have factored and factored and factored and factored. Well, three classes. We have factored and factored and factored and factored. So, of course, me factoring is no substitute for you factoring your homework, right? That's where you learn, for sure. Okay, so what is this? How do you deal with that? Well, we got to think about what we know, right? We know difference of squares formula, right? So we need to look at a to the 8th is really a to the 4th, right? Squared. And b to the 8th is b to the 4th squared. So we got to use our imagination like that. Once we do that, we say, aha, difference of squares. So this is a to the 4th minus b to the 4th times a to the fourth plus b to the fourth. So math majors know things that allow them to break this up. Are you guys math majors? Are you planning to be a math major? Okay, then we'll skip that part. So we're just going to leave that like that. All right? This part, though, we can do. Everybody can do this part. This is, again, same idea. A squared squared, right? Minus b squared squared, right? So you can look at that as the difference of squares. And so this factors into a squared minus b squared times a squared plus b squared times a to the fourth plus b to the fourth. But we're still not done. See, because we can still break down the first term because it's still difference of squares. But now it's just straight up difference of squares. So here it is. A minus b, a plus b, a squared plus b squared, a to the fourth plus b to the fourth. There you have it. I like this problem. It's pretty. If I like it that much, it's probably not in your homework. So, how about this one over here? What can we do? We're going to factor this guy. What should we do? First thing to always do in any kind of factoring problem is if there is no constant term, right? If there's at least an x in everything, you can factor x out. We can factor x out, right? X times what? Yeah, I'll do it over here so you can see me. This is x times 8x squared plus 44x plus 60. Now we can, maybe we can factor something out of that. Could you factor a 4 out of that? Maybe that would make life a little bit easier. I think we can factor a 4 out, right? So this is 4x times 2x squared plus 11x plus 15. Aha. Now I feel like we're going to be successful when we try this thing, right? Now this thing I did, it doesn't always work, right? So if that blows up in your face, then you got to fall back on completing the square for the quadratic, all right? But hopefully that won't happen here. How do we get 15? It's what? 1 times 15, 3 times 5, right? So what do you guys think here to get? None of them work? Golly. What was this, number 57? What's 11? 11 is, how do you get 11 from sums of things? Like 10 plus 1, 3 plus 8, 4 plus 7, 5 plus 6. That sounds like a winner because I've got a 2 here. I will need to build this 15 from, say, 3 times 5. So if I put 3 over here, right, and if I put 5 over here, then we're in business because we've got a 5 plus 6, give me 11. So that's a little bit tricky, right? No doubt, but there it is. Okay, so for the next test, how do you, how can you be sure that you have not left any gap in your defense, right? How can you make sure you haven't left the wall open for me to pillage and raid all the supplies of your village, take all your points from you, leave you famished for the winter? How can you keep me from getting inside the walls, right? You need to make sure there's no gaps. So how do you do that? You work the review for test 3, right? So I would encourage all of you to take the time to do that, because it's really easy to deceive yourself that you know how to factor when you actually don't. That's a good question. You guys have the course planner, the syllabus? Where to say in there? I don't have it in front of me. It can't be that long from now because there's only five tests in this class, right? And there's 5 tests in here, and we had 2. And it's been a week since the tests, which means the next test is upon us sometime soon. Can't be that long. I'm looking. I believe I think it's in the syllabus. Let's see here. If I can find your course. I should have worn my glasses. These words are small. Come on. This is kind of relaxing. I should teach from over here. Come on, open. All right. Yeah. Test 1, test 2, test 3 is March 11th. So, okay. I was a little bit wrong. You got a little bit of time, but March 11th, you'll be here before you know it, right? So, let's see here. In March 11th, it covers chapter 4, right? So, we're getting there. And we'll try to have the test review up for you guys sometime, probably this weekend, most likely. Well, maybe next Monday I'll have the test review up, I think. It'll probably be. I will try to get it to you by this weekend, but I'm just not sure. I got a lot going on this week. I'm not sure I'll be able to get to it. Now, if Professor Parker makes a review up, then I'll just use hers. All right. So, why do we factor? What's the reason for factoring? You're like, it's because you guys are mean, right? No, I don't know. So why do we factor? So factoring, what does this do? You take f of x, right, and rewrite it as product f of x equal to f1 of x, f2 of x, etc. Right? Basically, you're taking the given polynomial and you're rewriting it as a product of polynomials of lesser degree, right? This is factoring. So you start with an expression and you end with an expression, right? For factoring, it's all about expressions. You begin with a formula, you end with a formula, right? There's also equations, right? Solving, which is related but different. So f of x equals to 0 is kind of the generic form of that, right? So how does factoring help you solve equations? Well, if you can factor, f of x into f1 of x times f2 of x, then the only way that this can be 0 is what? Either f1 of x equals to 0 or f2 of x is equal to 0, right? So this is the point, is like by factoring, we're able to divide and conquer, right? Instead of looking at the entire polynomial, we can look at one piece at a time and see if it's 0. So for example, I forget which example I'm on. You guys remember? Seven? I'll take it. So, if I had f of x equal to x cubed plus 3x squared plus 2x equals to 0, that's kind of scary. What are the solutions to that? I don't know. But if I trade this for x times x squared plus 3x plus 2 equal to 0, well, I start to know something. I can tell from that that x equals to 0 is a solution, right? One more step. So this is x times x plus 1 times x plus 2. So how can I solve this equation? By making any one of these three factors 0, right? So this tells me x equals to 0, or minus 1, or minus 2. If we factor a problem completely, then I can solve the corresponding equation, right? So again, factoring, the answer is a formula with x. Solving, the answer is either, hey, there's no solution, or here are the solutions, which are numbers, right? But you see these problems are related, right? Being able to factor this cubic allowed me to solve this problem. Example 8. X squared plus 4x plus 9 equal to 0. Earlier this class, we completed the square on this. We had x plus 2. I'll do it again. X plus 2 squared. Oh, I had a minus 9 here before. Sorry, minus 9. So minus 4 minus 9. So this gives me x plus 2 squared minus 13 equal to 0. There are two ways you can go here, okay? There's two ways we can go. The one way we could go would be like, oh, wait a minute, I'm going to trade this for x plus 2 squared equals to 13. And then that tells me x plus 2 is equal to, and this is what you guys tend to get wrong, plus or minus the square root of 13. So x is equal to minus 2 plus or minus the square root of 13. Lovely. So that's one way you could go. The other way you could go would be to factor. See, this is x plus 2 minus the square root of 13. X plus 2 plus the square root of 13. So this gives me x equals to minus 2 plus root 13. This gives me x is equal to minus 2 minus the square root of 13. So those are my two solutions to this quadratic equation. Now, which way do you like to solve the problem? With what I wrote in white or with what I wrote in orange? It's totally up to you. I don't care. You can either look at it as solving for the square, and when you take the square root of a square, you get plus or minus, right? Or you can factor and look for the zeros corresponding to each factor. It's really up to you. Let's work another. Example 9. Suppose we have x cubed plus 4x squared plus 5x equals to 0. Solve this equation, right? Solve it. Factor x out, right? Then the question is, can we factor this? How do you do it? Ooh, but that would give me a minus 5. Tell you what, I'll be nice to you. I'm going to make this a minus. Then you're on point, I believe. Then Stuart's right. And we can solve it. What's our solutions? X equals to, first one gives me, how can I make x 0? I make x 0. How can I make x plus 5 0? I need to put x equal to, not 5, but minus 5. Minus 5 makes this 0. So that's another way to make this equation true. How to make this one 0? I have to put x equal to 1 to make that 0, right? So I put 1. So there you go. This cubic equation has 3 solutions. Let me mess up Stewart's factoring here. X cubed plus 4x squared plus 5x. And then what's going to happen to us? So here, I'll tell you what happens. So this is x plus 2 squared plus 1. See, when we complete the square on this quadratic here, we get a quadratic which cannot factor. So just think about it. Think about these problems, right? So in order to get this quantity times that quantity to be 0, how can you do it? You either get x equals to 0, right? Or you need x plus 2 squared plus 1 equals to 0. Is it possible to take x plus 2 squared and add 1 to it and get 0? Can you do that with a real number? Think about it. Can you add the square of a number? What's the square of a number? Take minus 3, square it. What is it? Minus 3 times minus 3, 9, right? Take 3 squared. What is it? It's 9. You take a negative number, you square it, it's positive. You take a positive number, you square it, it's positive. There is no way that x plus 2, whatever x is, can be something negative. Therefore, there is no way for this to cancel that. See, this is an impossible equation, right? No solution to this piece. Now, is there no solution for the problem? No, there is a solution for the problem, right? What's the solution? The solution is just right here, right? It's simply x equals to 0. That's your sole solution. So a cubic equation, sometimes it's got 3 solutions, like in example 9. Sometimes it's just got 1 solution, right? Depends on the problem. Just like a quadratic equation, it could have 2 solutions. It might have no solutions, right? Like, just let me make it real in your face here. Example 11. If we just peel off this x squared plus 4x plus 5 and we set that equal to 0, are there any real solutions to this? Well, there are not, right? Because this is x plus 2 squared plus 1 equals to 0. So this says no solutions, no real solutions. Game over. Here, let me give you one more example for today and we'll call it a day. Example 12. Suppose we have x minus 3 times x plus 3, times x plus 13 rather, times x squared plus 1 times x minus 8 times 2x plus 3 equals to 0. Solve. How would you solve this? The question is, how can you make the factor 0? If any one of the factors is made 0 by your choice of x, that makes the equation true. Because 0 times a bunch of other stuff is still 0. So we can think about them one at a time. Despite the fact that this is a big, ugly problem, it's actually 1, 2, 3, 4, 5 small problems. How about x minus 3? Can this be 0? It can. We just make x equal to 3, right? X plus 13, can this be 0? It can. We just make x equal to minus 13. Can x squared plus 1 be 0? It cannot. No real solution for this one. No real number makes this 0. I should have written bigger. My bad. X minus 8, can this be 0? That gives us the solution x equals to 8. How about 2x plus 3? Can this be 0? Now this one I can't do in my head. Well, okay, that's not true. I can, but let me pretend I can't. So this is 2x plus 3 equals to 0 is the last one, right? So what does this give us? 2x equals 2 minus 3. X equals 2 minus 3 halves. So there you go. There are 1, 2, 3, 4 possible solutions to this polynomial equation. This is why we've been factoring. Once we understand and master factoring, we can solve any polynomial equation that gets thrown at us, right? Yeah. See you guys Wednesday, most likely. Modulo, like blizzards, hurricanes, unexpected sports wins that make us cancel class. I don't know. Is that possible? No?